Me too. Hear what this interesting workshop is about.
So, hey. Thanks everyone. I know it's like an end of the day workshop and yeah, not many people here, but thanks for everyone who do sign up and come to our workshop. So my name is Jiahao Sang. I'm CEO of Block, and at Block, basically, the name itself is a pun about federated learning and blockchain. So that's why we named this one. And also, Block itself means a herd of things, right? So decentralized computation altogether. So that's basically the hype. The problem generally speaking, the problem that we're trying to solve is the privacy issue and the data silo issues, where we all know that more data means better machine learning models, but when it comes to different entities, different business competitions or regulations, it's hard to have those data all combined together to run some model, right? So that's why we have those barriers everywhere. So I'm gonna introduce our lead product to go in details about our solution and product details.
Yeah. Thank you. Maybe before I start, since this is going to be quite informal, I'll just introduce ourselves. My name is Shuoying. Before this, I worked as a consultant in BCG and then a bit in a crypto investment firm. I met Jiahao when we were both in Oxford, and the team is currently a team of 10, and we're working on this together, based in London, but also remotely. Yeah, as Jiahao said, the problem we're targeting is the concern about data privacy with growing usage of data in training machine learning models, as we all know, but also regulations creating data silos, which I've seen firsthand when consulting for the financial sector. Our solution makes use of two technologies. So the first one is federated learning. This was probably first created in the 60s and the 70s and popularized by application like Google Keyboard. So the main concept is that the training happens locally and the machine learning models can be trained without gathering data beforehand. So think about next word prediction on your phone. Because our conversation records are private, we don't want to share that with a big tech company. And the prediction models are trained locally without collecting all the data in one place beforehand. So that's federated learning. Where the problem is that currently all the implementations are in one big company because architecturally federated learning relies on a central server to get all the updates from the local models and aggregate them, and as well as coordinating in the training process, like which device to enroll, when to start a new task. So that means, although federated learning is great for privacy, it is difficult or resourcefully expensive to run because you need to have a strong enough protection on a central server, which can often be a single point of failure. So if I want to derail your project, I can just target that central server, and once that's done, there's no coordinator, and the project couldn't be run. So I assume everyone here is familiar with blockchain, if not, welcome. But the main purpose of blockchain is really you keep a record of the actions in every device that runs the blockchain. So there's no single point of failure, you have multiple people doing the aggregation. And also you have innate security in the proof of stake mechanism. So instead of a central party organizing who should participate in the training, you can use a proof of stake mechanism. So bad behavior gets slashed, and over time they lose their stakes and they get filtered out, and good behavior gets rewarded. And over time there are more incentive to stay in the ecosystem. So essentially, federated learning is here to protect your privacy and train models without collecting data, and blockchain is there to orchestrate the training process. So far, any questions? Feel free to jump in. This is a small group. Okay, I'll just carry on. And our innovation, in addition to bringing the two things together, we also have some ideas about making this more scalable by compressing the updates that you send, and also doing part of the aggregation off-chain and verifying it on-chain. That will be using zero-knowledge proof, which we are in the R&D stage, but we're hoping to roll it out as a Flock version 2. And Flock version 1 is what will be...
Question, what's version 1?
Yeah, a Flock version 1 is what we'll be demoing. So you see on the left-hand side, we have, this pointer works. We have each data source, and data source have a machine learning model deployed, and the training happens locally. And then you see this little arrow, which are gradients, or how you should update the models to achieve a lower loss, or how you should improve the models. And currently, these are sent on-chain, and the aggregation happens on-chain. So the final global model live on-chain. As well as running the aggregation function on-chain, we also run the incentive or reward slashing mechanism on-chain. So based on how good the updates are, the data sources or the model trainers are rewarded and slashed. So that's Flock version 1. In version 2, the key difference will be this part. The model updates are sent to a off-chain storage facility, so we're thinking either Arweave or IPFS, and the aggregation is done in an off-chain node, which is similar to a prover in a CKP architecture. And we have then verifiers doing the verification on-chain. So essentially, we only need the incentive or the coordination part to live on-chain. The global model doesn't have to be on-chain. And that will also help us scale. So that is what we're building. So we currently have the incentive mechanism done and the aggregation function, incentive function all done. What we envisage is that this will be a machine learning, decentralized machine learning platform with innate security guarantees. So thinking back to the problem of data silos, if I can connect all the data sources that are either individually in your health records on your smartphone, or your browsing history on your computer, or like with businesses, like for each bank, they have databases on what transactions are fraudulent, which ones are right, or healthcare organizations like under these conditions, this treatment work well. So we can connect all of those data silos while respecting their data sovereignty. So for them to get better predictions on when to flag a transaction, or for you to get better predictions on when you should move a little bit, or what exercise you should do, you don't have to sacrifice your data sovereignty. So that is our vision. We want to connect all the data, but allow people to really own their data, and doing so in a way that improves your service or satisfaction. So how this platform will run, we envisage this will be a token economy. So we have, I think, 4 main parties in this ecosystem. If this is how we're talking about an application to train a better health monitoring system, then we are the end users. But if we're talking about application that flags fraudulent or suspicious transactions, then end users will probably be banking providers. And then the next party is those who use Flock to train better machine learning models. This will typically be like either engineering department in the banks, or app developers who want to use better machine learning predictions to enhance their services. And then those are probably on the demand side, and on the supply side, who are the people maintaining the Flock network. So we have federated learning clients. Those are the nodes that do the training locally and share model updates. And then we have the blockchain nodes. So these are the people maintaining the blockchain so that we can run the smart contracts. And finally, for Flock V2, we will have the whole set of off-chain aggregator and verifiers. So they can help Flock scale and make sure you don't use unnecessarily large on-chain resources. And those four parties, among those four parties, we want to encourage people to share, to join the system and to plug in their data. So we'll give community incentives. On the other hand, we also need to reward people appropriately for their contribution to training the models. So there are rewards for model improvement, block production, and valid aggregation. Our main innovation in these settings are probably a reward for model improvement. We came up with a novel peer-to-peer powered incentive mechanism, which we'll go into more detail at the demo. And that is also the paper that won the Best Paper Award in Europe's blockchain workshop. If you're familiar with machine learning, Europe's is kind of a top conference, I'd say, and then finally, to incentivize early adopters, we'll have transaction fee burning, and the transaction fees here come from when model builders want to participate in training, they need to put on a stake. Stake to train is not stake to train, sorry, it's a typo. And when they send or receive updates, they'll have to pay in gas. So the larger your machine learning training task, the higher transaction fee you pay. And finally, if you just want to load the models from the training previously done on Flock or from elsewhere, you also pay a fee. So those are the transaction fee that Flock will receive as a platform, and part of it will be burned. So gradually, there will be hopefully a deflation rewarding early adopters. Any questions so far about solution or token economy?
I have a couple. One, assuming I don't know what state you're in, but what are you finding is the kind of near-term use case where I as an individual have a set of data and am motivated to participate in this network, given, let's say, what I can do commercially, either on device, on my Apple device, or what I can do using another cloud-based system?
Yeah, so is your question like why choose Flock over, say, Amazon machine learning?
Why specifically I as a consumer should choose Flock?
I think, well, for a consumer perspective, privacy should be your main motivation. So if you're using any other health tracking services, there is no guarantee that your data will be safe. So, and anecdotal evidence is, for women, there are quite a few period tracking applications. And then, well, those things should hopefully stay private, I'd hope so. But it was revealed that those data were then sold to Meta without notifying the users. I think with, more and more data being collected on users' health metrics, I have an Apple Watch, like Apple probably knows everything about me. There's growing burden of trust on the data providers. Beyond privacy, I think also monetization is a potential motivation. So currently, our data in the multiple apps creates huge model improvement for the providers. So there's a saying, if the product is free to use, you're probably the product, or something like that. So that means our browsing history and how we interacted with applications, they're essentially free training data we provide. But if with Flock, so how your data contribute to model improvement are measurable and they are rewarded. Does that answer your question, or you have more?
I mean, I have one follow-up to it, which is that, in my observation, sensor manufacturers, particularly biometric sensor manufacturers, are more or less designing their business models around capturing that data. So presumably what you would benefit from is, let's say, a sensor manufacturer that is, where the consumer is paying for that sensor and wants that privacy embedded in.
Yeah, like for businesses, it's probably another set of concerns. So for businesses, the biggest concern is probably data silos. But then for devices or sensors that are used to track those data, the bigger concern is data security, because the data are collected and stored in the cloud, but also the cost of running a computation, if you think about it, is quite high in terms of bandwidth, communication, and storage. So another anecdotal evidence, so currently a quite interesting example is decentralized clinical trial. So if I want to measure, if I'm a Alzheimer's patient, and if I'm taking a drug to cure it, one of the outcome people are tracking is how well you've improved in walking. So there are devices that are track how well you walk or how well you slept. Currently it is impossible with those devices and platform to just run yesterday's data or get real-time updates. Apparently to run computation takes $30, and a lot of it happens in transporting all the raw data. So the sensor, if you think about like a pedometer, a sensor that tracks how well you walk, collects 30 types of data per second, and that is a lot of raw data to transport. It is more efficient if you only transport and store what is needed for your outcome. In this case, will be gradients. Yeah. Any other?
So as a user, would I download the ML model and run on my smartphone or something, or the ML model is run on some node in your network?
So yeah, there are like 4 parties, and you can choose which one to opt in. So if you only want to be if you only want to be a data provider, then you just have to download the model. But if you want to download the model, and the model will be trained locally. But if you want to earn extra reward, you can become a FL client as well as a blockchain node. So that means you can earn the gas fee as well. Did that answer your question?
Yes. So I'm trying to think of the flow. So say suppose I own like an Apple smartwatch and my health data is going to some company, right? So in your case, would I, as a user, would I download the model and run all the algorithm on my, like say suppose a smartphone device, and then update it through the global system, or
Yeah, exactly. Yes, that would be.
Okay, so the user would actually download some machine learning model on their local smartphone and then run these computations.
But it doesn't have to be like user has to configure all this. So hopefully, when you click on join a training, like the model will be pre-deployed and then interact with your data and share the gradients. Yeah.
So like if I want to run like a ChatGPT model, which is very huge, right? So it would be very difficult for me as a user to download.
Yeah, I mean, it is large language model, so not feasible. But if you want to fine tune the ChatGPT model you received based on your habit, maybe that's a smaller task. So currently the demo we've done are more like manageable model sizes, 8 million parameters tops. So I don't think it's ChatGPT level yet. Yeah.
How do you guys account for like authenticity of data? So, I mean, your example of clinical trial. So, or say take cancer imaging, right? I have a data stream from multiple data sources, hospitals, whatever. what is the incentive to actually input correct data or to weed out data? Like, how do you guys account for that, or that's on the client side?
Yeah, definitely. That's one of the innovations, I would say. So I didn't include it in the deck because I thought I'll give too much detail. But essentially, we have two mechanisms. So if it's with businesses and a conglomerate, we have a signature system. So only data from this machine that provide this specific signature will be accounted for. But for like direct to consumer use cases, we will have assessment mechanism for how good the updates are. So once I submitted the local updates, or everyone submitted the local updates, the updates will be aggregated, and then there's a set of randomly chosen participants or FL clients as voters. So the voters, they use their holdout data or testing data to run the newly aggregated machine learning model. And if the performance has improved by, say, like 20%, which is configurable, then they vote 1. If not, they vote -1. And we aggregate all the votes. So if it's positive, the aggregation gets pushed through and the models are updated. And all those people who contributed to the update that round are rewarded. If not, those people are slashed. And in this multiple round game, we've run trainings where it takes 100 rounds. Usually you see in 20th or 30th round, obviously depends on the slashing ratio, you see the malicious proposers, which is people who propose random or bad updates, they're filtered out. Yeah. Do we have time for yes?
I have a question about how the data is partitioned. Like, for example, if the test set that you're using to validate the models on, if someone keeps submitting data that looks just like the test set, then wouldn't that just be more rewarded, or wouldn't the system reward someone who submits data that reflects a particular thing, or is it like you submit the data and that becomes like I guess my question is more toward like the accuracy. Like, how do you measure like the model improving? Because even if accuracy improves, it doesn't mean the model is better, right? You can have a lot of other issues based on bias.
This is actually a traditional problem captured by federal learning as a domain. So basically, there are different ways that in traditional federal learning, people try to play malicious. For example, yes, I can copy your data because I know you are ultra high net wealth. Your data is so valuable, I'm nobody. But if I copy your data, maybe I can get a good reward, right? Because I think I contribute to a good model. But then there are ways to remove those, because, for example, if the model is training across different entities, but when it passed from person A, B, and to you, and to the next body, you didn't give an increase into the model, then yeah, that's a signal where your reward will be less and less. So that's a way, or that's a traditional mechanism to remove those people who just copycats. But there are also other fancy ways of doing so. I don't have to copy yours, right? I can apply a normal distribution over my copied data. So my data now looks completely different, but it will contribute to a same set of improvement to the model. Yeah, so that's a tricky part. But thanks to machine learning, because it needs 10,000 or tens of thousands of runs to run a model, to fine tune a model. So with runs, eventually your increments, your gradient will be decrease. So that's how people identify, you're just a copycat. So yeah, these are the different attack mechanisms that happen to when we talk about collaborative learning, right? Because there are so many different behaviors within. So that's also what we described in our previous paper about. So how we use game theory as a mechanism to ensure the security, to eliminate those possibilities of the malicious clients. Okay.
And it's also possible to hide the updates or encrypt the updates, so it is harder to copy. Maybe one more question. I'll move on to.
So yeah, so in your when we're kind of at the model training one-time environment, in theory, at that point, if the data does contain features that lend towards de-anonymization, you can't really prevent that. So in theory, if I were to set up like a facial recognition model on your platform, and users were like sending me photos so I could age them for fun, I could basically obtain all of the facial feature data from all of those users, possess it locally, and there's really no way for you to invalidate that data store once I have it and I train on it.
I don't quite get it. So you're saying if app developer
Like if at some point I have to train my model right
Yes.
on the actual data, and so if the data contains features that could be de-anonymized, can you prevent that somehow?
are you talking about model inversion attack? So
Not
like
even just basic training, right? Like if you send me pictures of your face and I can, put that into a facial recognition app, I can append third-party data in the open marketplace.
yeah, but yes, yeah, but what is sent out, so to the chain or to the aggregator, is verifiable. So yes, to train the model, you will need access to the model, but you can verify that your data aren't sent out.
But how does the feature extraction work from an image, let's say, of my face?
Yeah, like once you sent out the gradients to build better models, there are multiple ways that on privacy measures to improve or enhance the security from the backward engineering. So, one is gradient compression. So if you compress most of the updates on the model, it is harder to reverse engineer what are the original data. But also you can have encryption when you're sending your updates, which are making it harder to reverse engineer. So I guess two things, like one is you can verify that your raw data never leave your device. And second, for the gradient, there are ways to compress the updates or encrypt the updates, making them harder to be backward engineered, which people call model inversion attacks. Our team currently a team of 10, but we didn't have time to put everyone on the slides, so if any team members are watching, sorry. Jiahao and myself, we're the co-founders, and to your point, if you're interested in the privacy measures, our lead engineer is running experiments on a new measure called gradient ensemble, which is a mixture of compression and mix-up. He'll be publishing that paper in a peer-reviewed journal, I think called Engineering something, and it will be updated. And then we have a group of PhD students working with us on the mechanism for flock V1 and V2. I think that's probably enough talking, and maybe we should see some code and a demo.
Yeah, sure. Just something to follow up on. Yeah, so as you mentioned, so there will be many people, once we have this channel live, let's say, there will be many people trying to attack it, right? So many fancy ways that we probably never thought of. That's why our strategy is research first. Well, also because from our backgrounds, I mean, even myself, I'm a research fellow at Imperial College London. So what we want to do is to make sure that we establish those domains with our research, with our front-end researches. For example, as we mentioned, the malicious clients elimination mechanism, which is published already, and then this year we have several more, including the gradient ensemble. Gradient compression is already something proven to be effective back in 2016, because by information theory, if something was compressed below 10%, there's no way that you can revert it back, because there's no way, right? So, and thanks for machine learning, if a gradient was compressed 10%, the only thing they need is to train more runs. So basically you are, sacrifice some of the efficiency, but still the privacy and accuracy is not sacrificed. And moving over from that gradient ensemble, or even, should we mention? zero knowledge. and zero knowledge. Yeah, because when we exchange gradients, we don't really need to exchange it, right? If there's a zero knowledge circuit, yeah, that's something we're gonna publish in summer. Yeah, so there are like different Lego plugins that we can use just to ensure security. So we don't transmit data. That's first of all. But still, yes, there are gradients. A gradient has its own risk still, right? Because Google once claimed that no, there won't be any version attacks on the gradients. But then soon after, people just yeah. So yeah, we are now pushing some new boundaries to see how we can solve it. So if there's any interest in terms of research, business strategy, feel free to contact us. We constantly work with academia or business or some strategic opportunities. Yeah.
I'm sorry, I want to ask a question about the tokenomics or the token economy.
Uh-huh.
I feel like you will have some kind of minimum
Stake.
no volume.
Uh,
A threshold beyond which the system actually becomes self-sustaining. Not just in terms of the number of people who are the users, but also nodes and not from a business standpoint, purely from like a blockchain standpoint. So have you guys run simulations on that? Have you kind of simulated the token economy itself? I'm curious.
Yeah.
Doesn't have to happen. I'm not genuinely
Yeah. So if you Google that paper, we have a graph at the end.
Perfect.
And obviously the viable number of nodes differ from federated learning side and blockchain side. So on federated learning side, from some task, 10 clients are good enough. But for the blockchain nodes, it differs for like how much you're setting your slashing ratio, reward ratio, and threshold to combine all that weights. So you can see some rule.
Oh yeah.
That was a short paper, by the way, for last year. So this year we're gonna complete it with more experiments and test iterations. So you will see the edge cases. Yeah. Right. So okay, I think we can go to our demo. This is actually something we just created. Sorry, this it's quite blurred. Sorry, but maybe on the screens are quite good. I'll just talk this through. So basically, we run we run a fork of Ethereum, and then we create what we call a flock chain, let's say, and then we have the nodes running on it, and then you see on the left hand side. What we're doing here is we have the simulator on, and that simulator is actually working with 10 clients 20, right? Yeah, 20 clients in our node, and then it comes with updates based on the data that they hold. So we don't know each of them what data they hold, right? So we wanna train together a model that can give us, for example, a credit score. So this is one of the use cases. So everyone don't want to reveal their identity, for example, if it comes to a Web3 wallet or Web3 lending type of things, because they still have to over-collateralize, because then there's no trust on those layers, right? But if you have your own, let's say banking data on your own node, and that can be learned and trained, and to provide a credit score, that credit score might be useful as a as an extra layer of evaluation to your Web3 wallet. And then that can give you a credit score, and it can maybe lower your collateral rate. And still, you don't need to worry about your identity was leaked, between on any Web3 wallet or any DeFi protocols. So so that's how, for example, if we join this, we'll see on my MetaMask, I have preloaded two wallets. One is a malicious client, one is a good client. So you'll see that this good client, it has its stakes. But then after different rounds, it earns more and more flow as a token. But then we change it to the malicious one. Yeah, that's a malicious guy. Yeah, the available token for this one will fluctuate a bit. For example, it will get a bit higher and then eventually it will go down, just like machine learning training. So any machine learning training, so it will, yeah, in the middle of the training, maybe there will be some bounce backs, but eventually this number will go all the way down to 0. So that's generally how we simulate this whole project.
In this context, how do you determine a malicious client?
Oh yes, in this context. So yes, so for our simulation, we actually we picked 3 of the nodes and then we give them very nonsense data instead of real data. So so these 3 guys will only, for example, when the model was passed on to them, right? They do not really train on the model. They just pass back a randomized matrix.
Yeah, we have 2. Like one is trained on raw data. So this model we have. What are the characteristics, and it is credit score, credit approval approved. So we have some malicious clients that train on the opposite label, and some malicious clients just send randomized updates. So the first one simulates the data poisoning attack, malicious clients, and the second one is probably the spammers. Malicious clients.
Yeah, we made it 3 because in an ideal case, well, in a reality case, there won't be that many malicious clients. But then in our paper, we pushed the possibility, to about 60%. Even that is still secure, so it should be fine. Cool. So yeah, that's the demo. Quite quick. So I would talk a lot of different things, but yeah, and we go back to the good guy. His balance is going up.
So like the smart contract is actually reading the gradient data and making those decisions about slashing things?
Good point. So we can go to our code base.
This actually based on multi-source.
Yeah.
So it's like an off-chain oracle.
Yeah. So the training itself is off-chain. Yeah. So this is our voting zone chain. Yeah.
But voting is based on reading the data off-chain and then making the decision.
That's right.
Yeah.
Yes.
So this is our project architecture, basically. Well, the Docker that runs, and then composed of 3 parts. First part is the front end, basically that's what you see as CSS, JavaScript, and then the middle one is the Solidity contracts. That contract facilitates all the reading all the modality, as you said, yes, and then making decisions, voters making decisions whether it's a good one or a bad one, and then to decide whether we give them more token or just eliminate all the tokens. And the last part is the Python part. The reason we use Web3 Py is because the majority of the AI models are well written in Python, so we don't want to reinvent anywhere else. And then yeah, we're gonna have that layer. So in our engineering side, we're gonna have that layer, working natively with PyTorch. So it's gonna be very easy for the AI engineers to adapt to this Flock framework. Yeah. And as for your question, maybe also related, this is the on-chain, off-chain map about where everything is. The front end what front end do is only reading the contract stats and events, and the simulator itself is communicating with the Flock manager that contract. That contract's doing adding proposer, adding voter, and staking, contribute, and get contribution, get global model, and then vote event title. And then, yeah, those are all managed by a single Flock manager contract. And then we have a separate contract, which is just like real wallet, right? Flock token contract that do allow you to put money out and allow you to make some money back. Yeah, so that's basically our current design and how it works. Right. That's pretty much everything. And so we are looking to open source this whole design and to involve more developers if you are interested. And also, most importantly, we are building our testnet. So this is only just a demo set. On the demo set, the wallet are per set, right? So the reason we want to go testnet is because we want everyone can try using their own newly created wallet. Don't use your main wallet, and then join the training and see how it goes. Yeah, so that's our future, let's say, several months that we want to target. So maybe if we are on time on East Paris or New York, we can have another workshop about our testnet announcement. So yeah, so now here, any questions? And also from developer perspective, if let's say Flock is going to have a testnet launch, from a developer perspective, how would you like it to be? And or in terms of easier for you to adapt or incentivize you to join?
So, in looking at this space, and I'm sort of a stakeholder in multiple companies, one that does generative design for novel molecules.
Mm-hmm.
There's such a demand for specialization, and none of those companies want to swap any of their data with anybody. Mm-hmm. They can get most of the data they need. So, what is the sort of jump-off point for your project? Like you said, I need my users to give me this kind of data, and that is how I go from my pre-seed to my seed.
Yeah. Thanks for the question. Basically, I guess that's more to the go-to-market strategy for the
first. What's your ask of us, right?
Yeah. So maybe for institutions, it's hard for different institutions to share. But our ask for a business pilot is to share different data on different entities that couldn't be shared during regulation. So if you think about the biotech company, I think it will be running trials in US, in Europe, and China, for example, but it couldn't pull all the data and the accuracy results together because of PDA regulation. So those are the data silos we're targeting. And the ask is, one, you have different entities signed up, and two, since it's one company, your data output, your metadata should be of a similar format.
I can also make this more straightforward when we talk about first bunch of clients, let's say, right? So what we're doing right now, so we are already applying a UK government fund together with Google, AstraZeneca. So that's what that's an 8 million bill that we want to perform clinical trial with them to see that with Flock to see that if this public verifiable framework can de-risk and can to remove those intermediates that we have to, for example, for traditional clinical trial, you have to recruit your patients, you have to hand out your devices, and then eventually you need to have a consent signed by every patient. And eventually when you get those data, you have to clean them all, right? So the angle that we're working at our first stage is working with very standardized cases like outlier detection. Because majority of the clinical trial, what they are trying to do is when you take the pill or when you take the therapy, right? Whether your condition, or whichever signal that they're tracking, whether condition have abnormal behaviors in one of the days, let's say 14 days period. So for those algorithms, first of all, those algorithms are quite set and quite simple to be deployed even in a Nokia phone, I guess. So sorry. Yeah, first of all, and secondly, because the device nowadays everyone has their smartphones, their Apple Watches, but these patients that would choose join the first batch of the pilots, for example, if they all have Apple Watches, the data schema is all the same. So that solves also another effort for cleaning the data. And secondly, very importantly, on Apple Watch, you can see clearly whether you toggle that data to be shared, right? So it's like from your side, you are already secured, oh, it's not shared. And also if you are smart, if you are keen to the blockchain technology, you can check on the blockchain and see how my data is never leaked outside of any open space information. Yeah, so that's why we choose work with healthcare at the first stage. because it's just like a set problem and a set angle where it's like a very feasible deployment that we can do as our first landing.
So signal processing, NLP, probably the two highest, and then maybe image classification would be your third tier.
Yeah, yeah, image will be,
But
yeah.
really clinical trials, mostly NLP data.
Yeah, yeah. Thank you. What? Any other questions? Comments or?
But by the way, I think what you're doing is super fucking cool.
Oh, thanks.
Yeah.
Wow, cool.
Like, you know, there's a ways to go, but I like the fact that you guys are going at it. That's, you know, it's not an easy problem, and not everyone sort of picks something as hard as this. So I really hope you guys nail it.
Thank you. Yeah, yeah, we are trying.
Could you maybe go into how you would compare to like Ocean Protocol that has, they have a similar system where like the data goes to, or instead of the data going public, the machines go to the data or something. But Ocean Protocol has some